Alright, in this presentation we're going to get into flip-flops and latches. Let's get started. So we're going to do a quick review of sequential logic and the flip-flop. We're going to introduce both D flip-flops, JK flip-flops. We'll quickly go through the flip-flop clock parameters. We'll talk about what a latch is, and we're going to talk about asynchronous inputs. Let's get started. There's a lot of stuff to do. Alright, so this is sequential logic and the flip-flop. So sequential logic uses AOI logic, or uses just any kind of combinational logic in conjunction with a clock. Okay, so as you can see here, this would be the inputs. The inputs along with the clock will give you a desired output. So let's look at a D flip-flop excitation table. Excitation table means that when, well, I'll just explain it and then we'll kind of go from there. So as you can see, whenever a 0 is sitting on the input and the clock rises, whatever's sitting on that input will be outputted. That's it. So we know that the arrow on a truth table here stands for the rising edge of the clock. So whatever is sitting on that input on the rising edge of the clock, that will be the output of Q. So in this case, 0 on the input, the clock rises, 0 is on the output. That's it. Now this right here is just not Q, so whatever is all that is just opposite of Q. So if a 0 is sitting here, a 1 sits here. Okay? And you know from previous activities that all you have to do is that right there, connect your not Q to D, and it will create a divide by 2 counter. Okay, here's a timing diagram, and I'm not a big fan of these, but I'll kind of show you very quickly how this looks. So your D is your input, the Q is obviously output. Okay, so whatever's sitting on that D when the clock rises, that's what gets set up, that's what gets outputted. Okay, so on this second rising edge, you can see that a D is on a 0. This output now falls to 0. On the next rising edge, there's a D. The output will now stay a D. Okay, next rising edge, now the D is high. So on the rising edge, now Q becomes high. And that's it. Whatever is sitting on the input at the rising edge of the clock, that will be the output. It's as simple as that. Okay, your JK flip-flop. Okay, it's pretty similar, except the only difference is with a JK flip-flop, obviously you have 2 inputs, both a J and a K. Okay, so here's how it works. Whenever the J and K have 0s, the output will remain the same. Simple as that. Okay, when the J and the K, when the J is 0, the K is 0. I'm sorry, the K is 1. So 0 on the J, 1 on the K. On the rising edge, it will clear the output. Okay, it's going to automatically clear. So no matter what's on there, it will become a 0 on the rising edge of the clock. Hopefully that makes sense. All right. When the J is 1 and the K is 0, it will set the output. And what does set mean? Set means that it will automatically output a 1. Okay, no matter what's on the output at that moment, when the J is at a 1, the K is at a 0, on the rising edge, it will set the output. And the set means that it will output a 1. And finally, when both the J and the K are 1, it's going to toggle. What does that mean? Toggle means just switch between 0 and 1. So when J and K are 1, let's pretend that a 0 was on the output. When the rising edge of that clock happens, then it will output a 1. We'll go ahead and we'll look at the timing. Okay. So the Q is your output, your J and your K. Okay. Rising edge of the clock. The K is 0, the J is 1. That is set, which means that the Q now outputs a 1. Alright? Looking at the next rising edge of the clock, both J and K are 1. Because they're both the J and the K are 1, it's going to output whatever is on Q, it's going to toggle it the other way. So currently, Q has a 1 on it. On that rising edge, it's going to toggle. It's going to go from a 1 down to a 0. Okay? We continue on. The next rising edge, again, both the J and the K are at a 1. Now it's going to toggle again. This time, it's going to go from a 0. The rising edge happens. It's going to go to a 1. So it toggled. Alright, moving on. Next rising edge. It's a 0 and a 1 on the K. It's going to clear, which means it's going to automatically become a 0. And that's basically how it works. Okay. We mostly deal with positive edge triggers, which means it happens or occurs, the change occurs on the front end of the clock or the rising edge. There are also negative edge triggers, which means that the change happens on the falling edge of the clock. Okay. That's basically what that means. I'm sure that we'll see some examples soon. Okay. Here's a D flip-flop. Notice that symbol there. The D flip-flop, all that means is that it's a positive edge trigger. Nothing changes with that. Now on this D flip-flop, you see it looks like an ice cream cone. That is a negative edge trigger, which means all this stuff is going to occur for the D flip-flop, but instead of happening on the rising edge, it's going to occur on the falling edge of the clock. That's all that means. It's the same thing though. Whatever is on that D on the falling edge of the clock will be outputted. That's it. So there's a positive edge trigger and a negative edge trigger. Okay, JK flip-flops work the same exact way. Alright. Both these guys are zeros. Nothing's going to happen. No change. When J has a 0, Q is 0. When J has a 1, Q has a 1. And with both J and K are 1s, then it's just going to toggle. Alright. That's just a quick review. This is a positive edge trigger. This is a negative edge trigger. Why? Because of the ice cream cone. Alright? Ice cream cones are bad. They're bad for you. Alright? They're negative. So, they're a negative edge trigger. So all this stuff with a flip-flop is still going to occur, but it's going to occur on the falling edge of the clock. Okay. Asynchronous inputs. That's these guys up here, the preset and the clear. Asynchronous means that they do not rely on the clock. Okay? They do not rely on the clock. When you synchronize, like you synchronize your watches are synchronized together to be on the same exact time. Asynchronous means that they're not on the same exact time. Time does not matter. Alright? So the preset and the clear, they are what's called active low. Well, what does that mean? Active low means that whenever they receive a low signal, they will spring into action. So what do I mean by spring into action? Well, let's start with the preset. Okay? When the preset receives a low signal, it is going to output a 1. Okay? It's going to output a 1. If it receives a high signal, it's not going to do anything. It's just going to remain the same. Okay? Let's look at the clear now. The clear. It's also an active low. Well, what does that mean? It means when it receives a low signal, it is going to output a 0 on the Q. When it receives a low signal, it will output a 0 on the Q. Okay? This right here is your truth table. Okay? And you can see here the first two, the top two, they're active. Again, these are active low. Right now, these have high signals. Nothing's going to happen. Nothing. These just stay there. It's like it doesn't even exist. Okay? Doesn't exist. But when these guys start getting low signals, for instance, here we go. This guy right here receives a 0. He is going to spring to action regardless of the clock. Doesn't matter on the clock because it's asynchronous. So when that preset receives a 0, it's going to automatically output a 1 on the cue. It's a preset, meaning this is what happens as soon as it receives a low signal. It outputs a cue. It overrides any inputs on the D. Doesn't matter. Okay? Let's look at the next one, the clear. When the clear receives a low signal, the same thing occurs. When it receives a low signal, it overrides everything. It overrides the input, it overrides the clock. As soon as that clear receives a 0, it's going to output a 0 on the cue. So the presets and clears, they're the same, but they're going to output different things. The preset outputs a 1, the clear outputs a 0. Finally, if they both receive zeros, it's an illegal condition, which means that it shouldn't happen. Okay? And if it does, it's just going to output a Q, or I'm sorry, a 1. But that's normally should not happen. All right, confusing, yes, but it'll get better. We're not going to look at the timing diagram for this. Just understand that the preset and the clear are asynchronous, which means they do not have to wait for a rising edge of the clock for them to control the output. Okay? They are asynchronous. All right. A latch. What is a latch? Well, think about a latch on a gate. A latch holds something in. Okay? Right? So if you got a dog and you put him in your backyard, let's draw a yard, right? There you go. So there's your backyard and you got a dog in there. Right? And you got a fence. Here's your fence. Now what happens if you don't latch that fence or that gate? What happens? The gate opens up, your dog gets out. Right? Well, in electronics, a latch works the same exact way. It's going to hold in the signal until the latch is allowed to open. All right? This is what I mean by it. Okay. That EN stands for enable. It's just like a clock, okay? But what happens is when this enabler or enable has a 0 on it, nothing happens. So what does that mean? Meaning that the output is going to stay the same on Q, no matter what it is. If a Q has a 0 on it, it's going to stay the same. If the Q has a 1 on it, it's going to stay the same. It doesn't matter. The enable is the latch is shut. Okay? When this latch receives a 1, now it's going to let out whatever's on D. So let's say that D has a 0 on it. When this enabler receives a 1, it's going to open the gate, or it's going to open the latch, and this 0 passes through, and now a 0 will be outputted. Hopefully that makes sense. All right. In contrast, let's pretend that there is a 1 on the D, on the input. When this enabler receives a 1 now, this enabler unlatches the input, and it's going to allow that 1 to pass through to the output. And that's all that is. So the enabler is like a latch on a gate, and it keeps everything on the D until it receives a 1. When it receives a 1, it's going to let whatever's on the D pass through and output. And that's a D latch. Here's a D latch timing. I'm not going to get into that, but you can see things happen on the rising edge of that enabler. So, what's the difference between a flip-flop and a latch? Well, the major difference is the enabler and the clock. Okay? That's really what it is. So the clock is your input, or the clock is what allows whatever to pass it through. Let me explain that a little bit differently. The clock deals with timing normally, right? That's basically what it is. And they're always edge sensitive, which means it's always going to happen on the edge, whether it's a rising edge or the falling edge. That's it. In a latch, it's level sensitive, meaning it's going to depend not on the rising or falling edge. It's going to matter on whether it's a 1 or a 0. That's it. That's all the differences between a flip-flop and a latch. Is there a lot of difference? No, there's not. Okay? We're going to use a latch just a few times, and then that's really going to be the end of it. All right. Here you go. We got a few different ones here. You got the D flip-flop, which is the 74 LS74. We're going to use those quite a bit. It's a positive edge trigger. How do I know that? Because I look right there. It doesn't have an ice cream cone. Positive edge trigger. Here's a 74 LS76. All right. It's a JK flip-flop, but this one is a negative edge trigger. Why? Because it's got the ice cream cone. Ice cream cones are bad for you. They're negative. Negative edge flip-flop. And here's the 74 LS75. 75. It's a quad latch. It's a latch because it doesn't have a clock. It now has an enabler. All right. This one is a little bit different. It's really not too big of a deal, to be honest with you, though. And there you have it. Okay. Here's the 74 LS74, the connection diagram along with the function table. It's really important that you understand how those function tables work. All the information you need to figure this stuff out is right there. If you can read a function table, you're going to be fine. 74 LS76, a JK flip-flop. Here's a connection diagram. Here's a function table. Once again, understand that function table. They have notes at the bottom. Those notes are going to really help you to understand what's going on. And here's the 74 LS75. It's an IC chip and it has 4 flip-flops in there. Okay. Again, it's really not too big of a deal. And that is flip-flops and latches.